Okay, now I am recording now, and thanks for reminding me about recording. Okay, let's continue. So yeah, so we're going to continue talking about two-factor authentication. One example is Google Authenticator, and the other is dual security. ASU uses this, so you probably already have dual security, like the app installed in your mobile phone already. Okay, and another interesting example is CAPTCHA. So CAPTCHA is short for completely automatic public Turing test to tell computers and human support. Some people also call CAPTCHA like as a reverse Turing test, because in this case is the machine test if you're human instead of like the human test if you're a machine. And you might already very familiar with this, like I suppose you already come across this many times, like from some websites asking you to type in those words so that it can validate that you are not a bot, you are a real human. So question here, is CAPTCHA authentication? What do you think? You think yes? Yes? Okay, I see someone shaking head no. Well, I mean, this is more of an open question. I mean, strictly speaking, if we really think about authentication, which is to bind the entity, like who is trying to make an action and the identity itself, then it's not, because you cannot really infer the identity, or you cannot really bind them, given just this, like CAPTCHA test. However, broadly speaking, it still belongs to this, because by the time that it binds this together, it's not really bind the identity with the specific identity, but it tells you that you are binding this identity with a human being, basically, right? So it's like it is in a broader category, not precisely that person, but at least it will give you some more information for you to authenticate. Yes.
So the CAPTCHA authentication, what is like stopping someone from somewhat programming the software to just type in the words on there?
Yes. So this is a great question. So there is some like history about this. Back to say 10 years ago, when machine learning is still not very well developed, or say like just like picture or text recognition from pictures, they're not still very well developed. It's only human that can recognize this like accurately and also in a reasonable amount of time. So that was the time that why it has like those words coming up and ask you to enter. But now, because machine learning has been so advanced, it's becoming more and more likely that, as I said, like a program that can automatically recognize this. And that's why, if you look at the current CAPTCHA right now, you will find that it's more complicated. Sometimes you will see like, object detection things, like giving you some figures, wants you to select those that contains like a cat, a boat, or something like that, right? It's just that it increases the difficulty for machines, but it doesn't increase too much difficulty for humans. So they're being developed more and more advanced. But yeah, then back to CAPTCHA for this specific example. Right now, it's not that secure anymore because of the machine learning techniques. All right. And then question how to break CAPTCHA. One possible way, as we just mentioned, is using like machine learning text recognition stuff, right? Like given the fact that we have a good machine learning results. Yeah, so those are the possible ways that you can crack this CAPTCHA stuff. And then there are more different other different ways of authentication mechanisms. So for example, like token-based authentication, like Google 2 FA, right? And then I don't know if you guys have experienced this, but like maybe I would say 3 or to 5 years ago, there was like a small key from ASU that like many staff at ASU use it. Like it's a key that can give you this token, and then every time that you want to log into ASU system, you can just take out the token and then see what is the next key. So it's like a actual like additional equipment that's only used for two-factor authentication. And it says, yeah, and then this is what they call hardware token. And also we have like address-based authentication, such as VPN that we mentioned last time, right? So it's like the way that it works is that VPN restricts the IP address, basically. So like everyone that only that on campus that can access a specific ASU's internal server. And that is a address-based authentication. Also, like location-based authentication, like those smart cars that you don't really need a key. As long as you're close to it, it will open it for you. It will recognize you, right? That is the way that you unlock the car, because you, first of all, you're close, and also it is, well, you have like the key or something that is attached along with you, so that it can recognize that you're the right person to unlock the car. Or biometrics-based authentication, right? Like you like our cell phone, most of us, our cell phones already have this biometric fingerprint readers that can you can turn on your cell phone and lock your cell phone with a fingerprint. Or voice recognition. Some of you guys, you may already set up in your like Google or Siri that only your voice should be received and recognized from your cell phone. So that is part of your voice recognition for authentication. Right, and then face recognition, again, like we use that a lot already for like door unlocking. I wish that there is a face recognition for our classroom. If that is the case, then maybe we don't have to wait outside for 30 minutes today. But yeah, so those are possible ways that we can do authenticate. And there is still a lot of interesting ongoing authentication research. What is called one thing is called a continuous authentication. It is to continuously verify the user, and then it will just like replacing the password. And the one possible example is FIDO. I'm going to replay this video for you if I can. Let me try. 1 second.
We live in a technology.
And then let me turn on. I'm not sure if it works, but let's see.
Enabled world.
Is there a cable? No, but I will just make this as loud as possible.
Times when technology lets us down. Take passwords, for instance. For users, they're clumsy, hard to remember, and they need to be changed all the time. For businesses, passwords just don't provide the security necessary to keep important data from falling into the wrong hands. With over 80% of corporate data breaches being caused by stolen or weak user credentials, the time for improvement in user authentication is now. And that's where the FIDO Alliance comes in. FIDO, or Fast Identity Online, is a consortium of the world's leading technology companies dedicated to changing the way online authentication is done. We're establishing technical standards that provide interoperable mechanisms that are far more secure and easier to use than passwords. From biometrics such as fingerprints and facial scans to second-factor authentication devices, FIDO's standards are allowing companies and service providers to better serve their customers and employees. Core to the FIDO approach is a personal device, like a PC, smartphone, or security key that uses a set of cryptographic keys to securely access FIDO-enabled services, such as Google, Facebook, or PayPal. FIDO authentication data, such as biometrics, is never stored with the service, which protects the user's privacy and shields their login credentials from hackers. But the best part is that users no longer have to choose between better security or a better user experience. With FIDO, they get both. Over 600 interoperable products have been FIDO certified, and FIDO enabling your product or service is easier than ever. FIDO provides a set of universal specifications to build to, and a rich ecosystem of products and services to enable turnkey deployment. Visit our website for more information on how to deploy FIDO authentication today. With FIDO, our technology-enabled world is finally becoming a safer place.
All right. That's a brief introduction about FIDO. This is like an ongoing research, and also it's like a movement that combines a lot of companies working together on making this like a continuous authentication possible. All right, and then the next is also it's about like authentication delegations such as OAuth. Many of you may already heard about that. Like if you're going to develop something using, API, say Google's APIs, then you are going to have this key to authenticate that or to denote that this is you yourself, so that you can use this API with the correct permissions, right? Yeah, so it's like for users to grant websites or applications access to their information on other websites, but without giving them the password. Okay, so that is, another way that we can handle this authentication, using like online, and also a way that, you show your self-identity, but without telling them the password. All right. That's everything for authentication. Any questions so far? All good? Okay. Let me also just check Zoom real quick. All right. I just see from the chat that someone cannot see the video. So if that is the case, then I can, it's in slides basically. So you can see the slides and then watch the video, and then the slides are already available online on our course website. All right, so that's all for authentication. And for the rest of the time, I am going to talk about our new released assignment. I don't know if you guys know about that. We have a new assignment released. It was today, today's morning. I am just gonna go over the assignment real quick to explain to you what's going on over there. And if we still have some time, I would like to walk you through some challenges from the assignment, hopefully 1 or 2 or 3, so that you will be able to finish your assignment in a more efficiently. Okay. All right. So let me reshare the screen with everyone. We can look at the assignment description together. And then I'm going to walk you through for this time's assignment. All right, and my Zoom friends, can you see my screen now, the course website? Awesome, thank you. All right, so this time for our assignment, it's about cryptography. So we're gonna have 2 parts of the assignment. One is asymmetric cryptography and the other is symmetric cryptography. Okay. And then for asymmetric cryptography, we're going to have this web of trust assignment, which is actually a pretty cool and pretty fun assignment. Before I talk about the actual content, I want to talk about the deadline first. So I was just reminded by one of you guys that this like March the 7th is in between, like it's in the spring break. If that's the case, then I'm gonna change the date. So it will not be overlapping with your spring break. So just so you know about this. So the deadline will be subject to change, but the assignment content is not gonna be changing. So yep. Okay.
Is it estimated to change to a due date before or after spring break?
Actually, when is spring break? Is it next week or the week after next week?
The week after next.
Okay, so I am thinking about maybe sometime that after spring break, but it's like it's probably going to be very close to the end of spring break. I would say maybe the first day after spring break. Just give you a heads up.
Thank you.
Yep. Okay. So yeah. So about Web of Trust, basically what you need to do is that you're gonna have a key that represents yourself. And then you're gonna use this key to show this to other people and have other people to prove that this is truly you. If you remember, when we talk about cryptography, we talk about public key, right? We talk about private key and public key, and then we talk about, okay, how can we or say how can the audience, how can the world make sure that the public key is correct, like the public key is truly from you and it's not forged, it's not modified, right? And one way to do that is to have a reliable third party to prove that this person's public key is truly from this person. And in order to have a third party to prove you yourself, you need to have this third party to so-called sign your public key, meaning that they're going to process something over your public key so that it will show that, okay, this reliable third party knows or also authenticates that this key comes from you yourself. So in this Web of Trust, or you call it like a key signing party, what we're gonna do is you're gonna have a public key on behalf of yourself, and then you're gonna find 30 people from the class to have them to certify you, have them to authenticate you, like by signing your public key. Okay. And also in the meanwhile, you're gonna become a bad person. So I'm also gonna give you a fake public key. And also you want to deceive and try to convince other people to sign your fake public key. Okay. So if you manage to have other people sign your fake public key, then you can get more score. And also if you manage to get like 30 signed key for your own, like the true public key, you can also get a good score. I mean, if you want to have a bonus score, then also you want to try to deceive other people to see if you can get a bonus one. All right. And I am looking at the chat right now. Okay, never mind. I'm just like looking at this and realize this is a joke. Okay, let me just continue. So yeah, the way it works is that you will need to log into your Grayscope, and then you need to generate first a GPG key by yourself. And you may just wonder how to do that, right? We have a lot of key creation guide. I really encourage you to read them, and they will give you, very detailed step-by-step instruction on how to generate a GPG key. All right. So you should be able to just like follow the steps and then be able to generate a public key for yourself. And once you generate that, you want to submit your key to Grayscale. And also you want to make sure that you don't lose your key pair, meaning that you want to make sure that you keep your private key all the time. All right. And when we check, later on when we check your assignment, what we're going to do is, you're going to submit your signed keys, and then I'm going to check your signed key with your submitted public key. So please make sure that you have your public key and also your private key saved properly. Okay, and then, after you have generated your key, you want to upload your public key. And also you want to get the class public key. So we have put our class public key here. You should be able to just like click in and download it. And here is the fingerprint. So you want to make sure that you get the right course's public key. And I'm going to leave you to decide or to learn how to fingerprint your key so that you can make sure that the public key that you download from the course website is correct with the fingerprint. All right. And then, as I said, you're going to have your public key signed by at least 30 fellow students. So you can contact other people during the class. You can also contact people through Discord or Piazza. Actually, I would say like do use Piazza as a good resource because it is supposed that everyone can access and also get the email from Piazza, but please do not flood other people's email. I do see cases happening that, like 1 hour or 2 hours before the deadline, and I received tons of email from the Piazza asking that, hey, I have this key, please sign for it, right? And I hope that you're not gonna make this happen because you don't really want to send 600 students those messages and have them sign for you at the same time. It was quite interesting. There are some possible strategies or possible ways that people do this from the past few years. There was one case that I was not experiencing this, but Adam told me this. Like there was one case 1 year that the student established a CA, like a authentication by themselves. It's like there are 2 students. They stand out and say that, okay, now I'm going to do this authentication. Everyone give me your public key, and then I'm going to be the hub and assign those keys for anyone else who submit a key to me, which is quite interesting. It's like, doing this favor and also forcing the community to sign keys for each other. Also, I want you to think about ways that you can deceive other people. You want to make sure that by the time that you sign the key to other people, you're talking to the true people, and that this people is giving you the right public key that represents himself or herself. It's not a wrong public key that represents someone else. So, but I'm not going to tell you some tricks, and then you're going to figure it out how to do that. And my suggestion is to really like read the public key that they give you very carefully, and make sure that the information there is aligned. Because someone can just change their public key. They can just change the name or change the information over there. So you want to make sure that those information is consistent. All right. Also, one thing that I want to remind you, which is very important, is that when you generate your key, it will ask you your name. It will ask you, in this key, what is your name? And please make sure that your name is exactly the name that is shown in our ASU system, because that is the way that we're going to validate you. Okay. And the way that you find your true name or the legal or principal name from ASU system is to go to my ASU, and there is a profile link page over there, and you can check what is your name there, and that might be different from what you think. Although you have your name, you may have a different impression for what your true name is, and this actually happened in last year. Because if that is the case, then you have to come back to me and regenerate your new key and then resign the keys from other people again. So I don't want to waste your effort. So make sure that you do use your true name, your legal name from the ASU system. Yes.
Is it case sensitive?
Yes. Well, I mean, that's a very good question. Yes, I think it is case sensitive. I would just copy paste the name from your profile, like from my asu.edu. So make sure that it's all, all identical. I do think that our current grading system make it a little bit flexible, like not really case sensitive, but just to be secure, make sure to be safe, so make sure that you are getting this case sensitive names. All right. And then, as I said, you want to make sure that you sign other people, your key got signed, but also you want to make sure that you're not signing invalid keys. Although, don't be afraid that, if you happen to assign other people's key, because the goal for this assignment is not really to reduce your score. It's more just like having fun and have a feeling about, okay, what is the real world looks like when you sign other people, or when someone try to reverse engineer you and lure you to sign a wrong key. So don't be afraid of that. You won't be like reduced for a lot of points. Mostly just for fun. And then after you, have your key signed with 30 people, you want to submit your public key again to Grayscope. And also, you want to you want to submit your adversarial key, like that key that we assign to you. And also, you want to get it signed by other people, and you want to submit that as well, so that we will know that what kind of bonus or what have you done when you be able to lure people. Okay, so yeah, so this is like the basic step for this assignment, Web of Trust. So I got some questions from chat saying that there might be a problem from Grayscope. Didn't see the Web of Trust upload. I will figure out that later, and if that's the case, then I will fix it. Also question how to check if the key exists in the system. So if you are asking about the way that you generate a key, then by the time that you generate a key, it will tell you where it stores. You can also, like, by the time that you generate the key, you can specify the places that you want to store the key. So you should be able to track the key, in a pretty straightforward way. You can specify that. And also usually when the time that the key has been successfully generated, you should be able to know where it is. Yes?
Are the TAs going to be participating in trying to trick us?
No, I don't think so. You could. I mean, by the way, Ian is one of our TAs, so that's a great question. Can TA help you with the train you guys to these things? I mean, if you go to the office hour, then yes, but I just don't think that there will be a separate sessions like today's lectures that have TAs to walk you through and teach you how to do the keys. It's mostly gonna be you guys read the web page, learn about yourself, and then and understand how to do that. All right. Okay, so that's about Web of Trust. Any more questions? Good. Okay, cool. And then let's talk about the symmetric part, the symmetric cryptography challenges. So we're gonna have 7 challenges from our Pong website again. So now if you click there, and you will be able to see 3 available right now. All right. So those are about AES. So we mentioned about AES, it is a cutting edge, extensively used symmetric cryptography, right? And in these challenges, you're going to learn the steps of AES and implement some component inside AES. So if you remember, it's the high level idea for AES is similar to DAS in the sense that it is rounded, symmetric key. So that the decryption key and the encryption key is the same. And it's going to take this key, do key expansion, expand it to multiple rounds. And every round it will have an operation along with the original text and the key together. And it's going to do that repeatedly to some numbers of a round and then output. And the process of decryption and encryption is pretty similar. All right, so for those challenges, you're going to do this. You're going to solve them. And a question here is, do we still do it /challenge/ something? And yes. So I am going to just work on one and show you one challenge real quick. I do see that we have some time. It should be 10 minutes should be good enough for us to solve one challenge, the challenge level 0. So if you have your laptop with you right now, you can also log into your account and then work on your challenges. Or if you don't, we can work on this together using my profile. But in any case, hopefully by the end of this class, you should be able to solve this challenge freely by yourself. All right, now I'm just starting the instance. Go to the workspace. All right, so here's the challenge. And 1 second, let me zoom this in. Cool. Okay. All right, so this is challenge, the first challenge, level 0. And you can see from the message that it gives you the key, or say it gives you the message as the encoded result of the key, basically. And then it tells you this is the way that it encode the flag. So as I said, the way that it works is that it will convert each of the letter to like the ASCII and then output the hexadecimal of the ASCII value. And then here is the message of the for the corresponding flag. So the question here is how you need to do in order to kind of decode this message back so that you can get the flag. All right, I will give you 3 minutes since we're running out of time. But after 3 minutes, I will talk about the solution. And also let me know if you already solved this by yourself. Also, by the way, you may already notice that this is a Python file. You can open it and then read it. That's not a problem. All right, time's up. Has any solved it? Anyone from Zoom solve this challenge? Okay, so here's the solution. This challenge is actually pretty straightforward. Let me just let me reshare my screen. Okay, so the way that it works is that remember that we have, you know, like for each of those um, letters, which is the flag, right? So it's like from the letters of the flag or the characters of the flag, I will first make it to get this ASCII, right? And then it's gonna have this hexadecimal value for each of the ASCII. So if you have Python, what you really can do is that you can convert the string itself to the bytes. So the way that currently is encoding, like the way that it encodes the message is exactly the way that Python converts from byte to a hexadecimal. So in this case, all you need to do is to use the bytes function, like the bytes, byte, and then there is a specific function called from hex that it will help you to recover the bytes from the hexadecimal values. So right now I'm gonna just first put the message here. Okay, so this is the message. And then I'm gonna do is byte doll from hex message. And you got a key. Okay. Yep. So it is very simple. You just need to use this function byte from hex, and you will be able to recover this key. All right. And in this assignment, you will be heavily using this like transformation or this conversion. When we give you some like encoded or encrypted message, we don't want to give you unreadable bytes, make you confused. But instead, we will encode it in this way when we send that to you. So you will need to read in those strings and then convert it back to bytes, or like any kind of like integers, so that you can continue to operate on those values. All right. Yep. And then all you need to remember is this command. And also, if you want to like kind of convert it back, what you could do is say this is the flag, right? And then you do flag hex, and you got it back. And you may also need this way to output back to the value, because you may need to interact with the future challenges when you have those values. All right. Okay. So that's everything from today. There are 2 more challenges over there. So my suggestion for you guys is that starting from level 0, so try level 0 and level 1. And these 2 levels tells you how to encode the message correctly, and then do level 4. And later on, you will have more challenges. And there was a specific levels, level 2, that asked you to do like entire high level operations on AES. And that is probably the most tough challenge. If you can't solve that challenge, I will just skip it instead of like spending a lot of time over there. Okay. And I also put a warning message in the challenge itself already. So if you see that warning message telling you that you may want to skip this challenge if this costs you too much time, then yeah, just do that as what I suggested. All right. That's everything about today. Thank you.